Napier's formula. One of the most important questions which we use in majority of the application problems. In a triangle ABC, we have tan A minus B by 2 equals A minus B by A plus B cot C by 2. Notice here I have capital AB. The RHS is a combination of AB, small AB, that is the sides. Here I have AB in tan. RHS I have cot in C. So A minus B by 2, here I have cot C by 2. Similarly, the other two formula. To show the formula, the very first one, let us try to prove. Start from RHS. In RHS, I have small a and b. Let us remember sign formula. A by sin A equals B by sin B equals C by sin C equals 2R. Substituting from which I get A is 2R sin A minus B is 2R sin B divided by A 2R sin A plus B 2R sin B. Cancelling all the 2R. I have sin A minus sin B divided by sin A plus sin B. You have cot C by 2 which we retain as it is. What is sin A minus sin B? 2 cos A plus B by 2 sin A minus B by 2 into cot C by 2. Denominator 2 sin A plus sin B. So 2 sin A plus B by 2 into cos A minus B by 2. 2 and 2 we can cancel. Cos by sin is nothing but cot A plus B by 2. Sin by cos is tan A minus B by 2 into cot C by 2. To have a clue, let me refer to the LHS. The LHS is tan A minus B by 2. Only this part I need. So the other two must naturally get cancelled. How to cancel? Remember, we are in a triangle where A plus B plus C is 180. I want A plus B. So A plus B is 180 minus C. And I want by 2. So divide by 2 throughout. It is A plus B by 2, 180 by 2 C by 2. Or I get A plus B by 2 is 90 minus C by 2. I want cot. So cot A plus B by 2 is cot 90 minus C by 2. Remember, 90 comes change. Cot will become tan C by 2. First quadrant, all the ratios are positive. So tan C by 2 is also positive. So in the place of cot A plus B by 2, I can put tan C by 2. So tan C by 2, tan A minus B by 2, cot C by 2. Remember, tan into cot is 1. So tan A into cot A is 1. Why? They are reciprocals. So I am left with tan A minus B by 2, and that is the LHS and hence the result. Similarly, I can show the other two results. And thus we have proved Napier's formula. Let us recall, starting from RHS, A minus B by A plus B. We are using sign formula. Cancelling 2R by taking common. We are left with sin A minus sin B by sin A plus sin B. This is 2 cos A plus B by 2 sin A minus B by 2. And denominator 2 sin A plus B by 2 cos A minus B by 2. Cos by sin is cot, sin by cos is tan, and cot c by 2 we write as it is. We need only this term in the LHS. That means the other two must get cancelled. So how to do it? We try to rewrite using the triangle idea a plus b plus c 180. If a plus b plus c is 180, a plus b is 180 minus c, dividing by 2. Taking cot on both the sides, I get tan c by 2. Tan c by 2 and cot c by 2 we can cancel because they are reciprocals. Having cancelled these two, I arrive at LHS. Similarly, we can prove the remaining two, and hence Napier's formula is proved. We are going to derive area of the triangle ABC. We have learnt many formula in the previous classes. Now, we are going to use the trigonometrical idea in deriving the area of triangle. See the formula. It is half AB if I put sign of the missing letter C, angle C. Half BC I put the missing letter capital A. So two sides if I take BC, angle will be A. Two sides if I take AC, angle will be B. Two sides if I take AB, angle will be C, and we have three different formula. The working is very simple. Let us consider the triangle ABC. Drop a perpendicular AD so that ABD is a right angle triangle. I can also say ADC is right angle triangle. From ABD, what is sine B? Let me write. I want sine B in my question. So what is sine B from ABD? It is opposite by hypotenuse. AD by AB, or I will say AD by C. Cross multiplying AD equal to C sine B. Use the result to find out the area of the triangle. So, area of triangle ABC. The usual formula, half base into height. In this question, base, let me take A. Height is nothing but AD, the vertical height. But what is AD from this step? It is C sine B. If I take this triangle, I will get B sine C. If I tilt the triangle, instead of A, B can be on top. We derive the other results. So generally remember, area of the triangle, we mark a triangle symbol delta, which is half AC sine B, and we can show the results similarly. So area of triangle, as we had learnt many formula in previous classes, let us remember, if two sides, say B and C, and the included angle A is known, I can use it. Two sides A and B and the included angle C is known, I can use in this way. Two sides A and C and the included angle B is known, I can use it. So generally in problems, in practical life situations, if I know the two sides and the included angle, I can definitely find area of the triangle. Half angle formula. Sin A by 2, cos A by 2, tan A by 2. We have a set of formula using the sides of the triangle and S. What is S actually? It is A plus B plus C by 2, or I can say 2S is A plus B plus C. So S we can term as a semi-perimeter. To show, let us start from LHS, that is sin A by 2. How to write it? I can write it as root of sin square A by 2, which is 1 minus cos A by 2. We know the formula. Cos 2A equals 1 minus 2 sine square A. Using cos 2A, that is 1 minus sine square A, I can write 2 sine square A is 1 minus cos 2A, or sine square A is 1 minus cos 2A by 2. In this question, A by 2 is coming. So, I will put 1 minus cos A by 2. Let us remember what is cos A. Cos A is B square plus C square minus A square by 2BC. The whole thing divided by 2. Taking LCM, 2BC minus B square minus C square plus A square divided by 2 into 2 I can put, because both are in the denominator. The next step. This can be rewritten as A square minus common B square plus C square minus 2BC divided by 4BC. That is A square minus B minus C the whole square by 4BC. Or we can write, it is A square minus B square pattern. A plus B minus C into A minus B minus C divided by 4BC, which can be further written as A plus B minus C into A plus C minus B divided by 4BC. Let us remember 2S is A plus B plus C. So 2S minus C will be A plus B, or 2S minus B will be A plus C. Since we know 2S is A plus B plus C, A plus B can be written as 2S minus C and A plus C can be written as 2S minus B. Substituting here, A plus B will become 2S minus C. So as we substitute, it is root of 2S minus C into the second term is A plus C, that is 2S minus B divided by 4BC. The next step, we can rewrite this as 2S minus 2C into 2S minus 2B divided by 4BC. Taking 2 common, S minus C. Again taking 2 common, it is S minus B divided by 4BC. 2 2's are 4 getting cancelled, leaving us S minus B into S minus C by BC, and this is the formula for sine A by 2. Similarly, we can prove sine B by 2 can be written as, see, when I want A, it is a combination of BC. When I want B, it will be the combination of C and A. Denominator AC will come, and sine C by 2 will be root of, C comes in left, AB combination in the right, S minus A, S minus B by AB. Instead of sine, if I want cos, what should I do? Just reversing the steps from the beginning. Sine square formula 1 minus cos. Cos square formula 1 plus cos. So I put plus everywhere. And as we simplify, we arrive at this answer. So the only step here, instead of minus, I put plus. Successively, by taking LCM and simplifying, we get cos A by 2. Once I know cos, sine divided by cos gives us tan. Now this formula plays an important role in deriving Heron's formula. State and prove Heron's formula. This formula is named after Hero of Alexandria, who is a Greek engineer and a famous mathematician. This formula can be used to find the area of a triangle when we know all the three sides A, B and C. We need to calculate, yes, the semi-perimeter, which is A plus B plus C by 2. And the formula states area of triangle is square root of S into S minus A into S minus B into S minus C. How are we to prove it? We know area of triangle is half BC sin A. This S minus A came in half angle formula. What I know, sin A by 2 cos A by 2. So, I can rewrite sin A using sin 2A formula. Sin 2A is 2 sin A cos A. So, sin A will be 2 sin A by 2 cos A by 2. If 2A comes, it is A. If A comes, it is A by 2. So, we write half BC sin A is written as 2 sin A by 2 cos A by 2. 2 and 2 I can cancel. What is sin A by 2 from here? So this I write from the second formula, and this I am going to use the first formula. Sin A by 2 is root of S minus B S minus C by BC. Cos A by 2 is S minus A by BC. BC into square root of BC will become BC. The numerator, I have S minus A, S minus B, S minus C. BC cancels, giving us the formula delta is root of S into S minus A into S minus B into S minus C. Now this formula is possible provided we remember the half angle formula. So learn to derive half angle formula or remember it to substitute to derive Heron's formula, which is very important under 2 and 3 marks. As we have learnt Heron's formula, that is del equals root of S into S minus A into S minus B into S minus C. We would like to state that for a fixed perimeter, equilateral triangle has the maximum area, and maximum area is S square by 3 root 3 square units. Based on this, we have some exercise problems. Exercise 3.9, question number 9. An engineer has to develop a triangular shaped park with a perimeter 120 meters in a village. If the park is having the maximum area, find the dimensions of the park. Given perimeter. So the question, already we have used this formula. Given perimeter 2S equals 120. S is equal to 16. For a given perimeter, maximum area equals S square by 3 root 3 or 60 into 60 by 3 root 3. Cancelling 3 with 60, I get 1200 by root 3. Multiplying and dividing by root 3, we get 1200 root 3 by 3, or I can say 400 root 3 meters, so it is meter square. Now to find the dimensions, it must be an equilateral triangle to have a maximum area. So A equals B equals C tells me all the sides are equal to A. So 3A, the perimeter is 120, or I get A is 40. So the dimensions are 40 meters each. 40 meters. 3 sides are there. So each side we will say 40 meters. Exercise 3.9, question number 10. A rope of length 12 meter is given. Find the largest area of the triangle formed by this rope and find the dimensions of the triangle. Perimeter of the triangle is nothing but the length of the rope, that is 12 meters. So S is equal to 12 by 2, that is 6. What is the maximum area formula? S square by 3 root 3. Or I can cancel and I get 12 by root 3. So area equals 12 by root 3 multiplying and dividing by root 3. It is 12 root 3 by 3, or we can say 4 root 3 meters square. It must be an equilateral triangle to have maximum area. Look at the question. We are given largest area. So it must be equilateral triangle which states that all the 3 sides are equal. So A equals B equals C tells me all the 3 sides are A. If I take 3A equals, the perimeter is 12. So A equals 4. So the dimensions are each side to be 4 meters. And that is the problem. So the dimensions of the sides, we have 4 meters each. And hence the problem.